Hello, everyone, and welcome to today's webinar, From Challenges to Tangible Benefits, Optimize Time, Costs, and Quality with Breton Genesi Large Format 3D Printing. Today's webinar will be recorded, and you can find it online on the 3D Natives website after this session or on the 3D Natives Vimeo channel. So if you miss anything or can't stay for the whole time for any reason, a replay will be available. Before getting started, I'm going to share a poll, and we just ask that you answer these questions so our speakers get a sense of where you're coming from and your experience and what you're looking for. So if you could take a chance to answer these three questions, I will be closing the poll at the end of the introduction and sharing the results. So if you could do that quickly, that would be amazing. Thank you. So before getting started, I'm going to introduce everyone. I'm Julia Steiner, English Content Specialist at 3D Natives. And as you know, 3D Natives is the largest online media platform for 3D printing. And with us today, we have our experts from Breton, Ariana Toncelli, who's the Strategy and Marketing Director, and Enrico Bragagnolo, Sales Area Manager. So Ariana is responsible for defining market strategies that promote technical innovation and strengthen the company's global presence. Her contribution is key to driving Breton's growth and brand evolution in international markets. Since 2000, Enrico has been supporting customers in their investment and improvement processes, helping them to increase their efficiency and flexibility through the adoption of Breton additive and subtractive technologies. Now I can move on to the agenda. If you could go to the agenda slide, that would be great.
Yeah, I'm trying. Yeah.
Mettete la slide agenda.
Thank you for your patience. Thank you so much. So first, our experts will be defining large format additive manufacturing, talking about what it is and its place in the market. Then they'll dive into the Breton Genesi ecosystem, following it up with an explanation of their Canova software. Finally, they'll explore some applications and really delve into what this technology is capable of creating. And at the very end, we'll have 15 minutes for a question and answer section. At any time during this webinar, please feel free to put your questions in the Q&A section at the bottom of your screen. If you don't put them there, we won't be able to see them, so please do not put them in the chat section, but specifically in the Q&A box. Also, if you look at the Q&A box, you'll notice that there's little thumbs up where you can vote for the questions that interest you. So it's just a way for us to gauge interest in questions, and they'll be ranked by interest. So please feel free to do that. Finally, if you haven't had the moment to answer the poll on your screen, please take a moment to do so. As after I finish with this introduction, I will be sharing the results. So just a reminder. Anyways, so large format additive manufacturing is really has a booming market. And as you can see from this graph, the total large format machine revenue from 2021 to 2030 has been growing by the hundreds of millions every year. So this is really a technology that's in demand, it's rapidly evolving, and it's applicable to so many diverse industries, from aerospace to automotive to construction. All of these industries that are seeking large and lightweight and durable components are turning to large format additive manufacturing. So it's very exciting to be at the forefront of this technology and explore everything that it has to offer. So now I'm going to close this poll and share the results. So you should be able to see the results on your screen. So for the first question, it says, which do you think is more feasible for your business? And 36% of you answered that investing in an in-house LAM technology would be feasible. And 48% answered that collaborating with external specialized suppliers. So what that tells me is that there's a mix here of people looking to have LAM in their own business and other people who are looking to outsource, which is good to know. And then for question 2, are you familiar with LFAM thermoplastics or using thermoplastics? A majority of you, 64%, said yes, which is great. Finally, what are the most interesting aspects that would motivate you to adopt LAM in your business? And 64% of you answered the possibility of producing complex shaped parts. So, sounds great to me. Speakers, I hope you take that information into consideration. You get a little feel of who's here with us today. I'm going to stop
Yeah,
sharing
thank
the
you.
poll and I will pass it on to you. Thank you so much.
Thank you, Julia, and thanks everyone for taking the time to be here. So today we're diving into a fast-evolving field that's really catching the eye of the manufacturing world, which is 3D printing, especially in its large-scale applications with thermoplastic materials. But before we dive in, let's go over some common definitions. So what do we mean by large scale? We define large-scale additive manufacturing not just in terms of size of the machine, but also of industrial applications, part size, throughput, and production environment. And it's not only for prototyping, but also it's also aimed at production-ready components. Just to clarify, we're referring to additive FDM processes, that is fused deposition modeling, primarily with thermoplastic pellets reinforced with carbon fiber or glass fiber. And we are actually broadcasting from inside our own additive manufacturing center, which I would say is much larger than the studio that I was renting out when I was a student. And this is our largest 3D printer. It's modular and it's capable of printing parts with dimensions that can reach up to 30 meters long, 5 meters wide, and 2.5 meters tall. And the extrusion capability of the system goes up to rates of 200 kilos of materials per hour. We call the system Genesi because we were inspired by the concept of endless possibilities of creation. And Breton combines the expertise in vertical high-speed machining centers with state-of-the-art extrusion technologies. And these systems can be pure additive or hybrid. So additive plus subtractive technologies in the same machine. This technology is a real game changer in many sectors, from aerospace to automotive, opening up new possibilities for both production and design. But Enrico, could you give us a general overview of the current state of large format 3D printing, and also in your experience, what are the main drivers behind its growth?
Thanks, Oriana. Hi, everyone. Yeah, I'll do my best to provide you with a good insight of the large 3D printing, or LAM, large additive manufacturing, because as you mentioned, the demand for these technologies and systems is really booming in several sectors of the industry, like in the aerospace, in marine, automotive, precision engineering, and including architectural and design. Well, there are several key drivers behind this growth of the large additive manufacturing. At first, the ability to create in one shot big complex geometries offers incredible flexibility. It opens up the doors to design freedom, essentially, right? A dream for the engineers, basically. Yeah. And then companies are looking to cut lead times and optimize costs. So they are looking for solutions that let them produce maybe more complex part and maybe in even less time. Another big factor is the focus on sustainability. 3D printing lets you use only the material you need, reducing waste, and it allows to cut a lot of the logistic and transportations. And finally, for the most innovative companies, I think adopting large-scale 3D printing is also a real opportunity to transform their entire business model.
So that sounds really fantastic. And the advantages to me are pretty clear. But Enrico, I would ask you to dig a bit deeper and tell us from a technical and operational point of view, what are the main benefits that companies get when they adopt large format 3D printing in their production processes?
Of course, Ariana, the technical and operational benefits of large additive manufacturing are really significant here, so I'll do it. Like I mentioned, reducing the global lead time is a key factor. So being able to extrude more material per hour means not only the capacity to increase productivity and so the ability to satisfy maybe a higher demand, but it's also about lowering operational cost with a better return on investment for the machine and a dramatically better use of the resources. Another important point is the improved printing quality. With our solution, we are extruding larger beads, some beads like the one you see now at the slides. And this makes the layers more compact and solid, which improves the mechanical property of the parts and gives you better surface quality, even after milling if it's needed. Plus, being able to make monolithic parts with intricate geometries open up new possibilities for design and functionality. Particularly if we compare it with the traditional way of producing maybe large parts as assemblies of multiple smaller components, which is quite a tricky job most of the time. And let's not forget sustainability. So using less material means less waste. This is quite obvious. If I can print my large tooling in-house, for instance, I can also cut a lot in transportation and logistics.
All of these aspects are both fascinating and also full of potential, but sustainability in particular stands out to me as one of the most promising frontiers of additive manufacturing. For instance, in Breton, we have been actively exploring this dimension with experimenting with the extrusion of recycled biocomposites, such as the ones where we are sitting now.
Yeah.
And we will see some other examples later on. But yes, as you mentioned, large format additive manufacturing is a real shift in production paradigm for many industries, including the ones that are traditionally open to innovation. And adopting this technology, especially on a large scale, comes with its challenges. And in your view, what are the main issues that companies face in this transition?
Well, you're perfectly right. Despite all the advantages that we have on the large format additive manufacturing, there are, of course, some challenges. When it comes to adopt in a way the LAM with thermoplastics. And in fact, one of the main ones is managing the extrusion process in a large scale. It's a thermoplastic extrusion process, so you need well-defined and stable parameter throughout the print cycle to get reliable results. If parameters like extrusion speed, temperature, or how the machine handles around corner are unstable, you can get geometric defect and lose mechanical properties. Also, a lot of solutions on the market tend to overlook things like fluid dynamics and temperature management of the deposited materials, often leaving these critical aspects up to the operator's experience, requiring skills that, let's be honest, they are not very easy available out there. That makes it hard and quite difficult to bring it to high quality results. Another challenge is also about the preparation and all the phases that we have before getting to the print model, especially in professional 3D print. It's what we call the ability to make a good design for printing. Was creating the designing of a mold, for instance, should define from the first input how the machines should behave or how the printed layers should go on the machines. And finally, I think it's important to remember that large-scale extrusion isn't just about size or material quantity. It takes also quite a lot of research to produce parts that could be competitive, both in terms of performance and cost.
I see. So one of the first things that I learned in my career is that the process drives the outcome.
Sure.
And so it's crucial to manage the extrusion process to get the results that are at the same time consistent, high quality, and competitive. And how does the Breton Genesi solution tackle these challenges that are relevant to so many industries?
Exactly, Ariane. Breton comes from a solid experience in vertical machining centers for many different materials, including the most exotic composite materials, and it combines it with extrusion technologies at the state of the art. With these joint skills and joint experience, we develop a range of products dedicated to large additive manufacturing with thermoplastic materials. Genesi isn't just a machine or a regular FDM printer. It's what we define as a real ecosystem that integrates machine learning algorithms and advanced artificial intelligence systems, all with a scope to optimize additive manufacturing process.
So I'll stop you right there because it sounds all very nice, but everyone today is talking about AI and machine learning. So it would be useful if in practical terms, you could explain how Genesi truly helps to overcome the challenges that we discussed, harnessing AI and machine learning for issues like, I don't know, parameter management or process complexity.
Yeah, you're absolutely right. Theory is great, but what matters is how it works in practice, right? So let's go into it and see how the Genesi system works. Let's follow it along with these slides too. As we mentioned, the Genesi system that uses artificial intelligence and machine learning to make printing better and more reliable. In practice, this means the machine doesn't just follow the standard instruction from the design software. It goes a little bit further, and it brings the experience from Breton technicians and customer print results into the application of the new prints. Essentially, Genesi learns how to always get to the best outcome. So even before printing starts, the machine can sort of predict and optimize the print instruction. And if something unexpected happens during the print, Genesi can also adapt and correct the setting on the fly without you having to step in. Let's look at a concrete example. If you're printing an object for any kind of reason, the conditions around the parts are changing, I don't know, the temperature, the proximity to other parts, the humidity or whatever. Genesi notices right away and automatically adjusts parameters like printing speed, material flow, layer adhesion temperature, and so on. This way, it always gets high quality results in a stable way without manual interventions. And let's take another example. Breton already provides a ready-to-use set of recipes for printing with many different materials. But if you want to use a new material, you can always work with the Breton team to identify the right parameters, tune them at best, and then the machine automatically saves them, and you can so use them for the next time with all the, let me say, the straight approach that you get with the standard database. In short, let me say, if we want to take a simple example, Genesi is like a car that doesn't just follow the GPS, but also in a way senses the condition of the road, if there is traffic or rain, the changes on the route or the speed, in order to always get you to your destination in the best way. So you can focus on your project without worrying about every little technical detail of the print.
And besides the machine, what else does Breton offer to make 3D printing easier?
Yeah, Breton for sure didn't stop to building and engineering the 3D printer. We also developed an intelligent software called Canova, designed to make life easier for people working in production.
And how does Canova help the operator?
Well, it's really simple. It's essentially in a form of a wizard. So that the operator can easily follow. So the operator essentially just import the layer path from the slicer, then it picks the material from a ready-made database without losing time in defining the parameters because they are already there. The operator also select which type of nozzle you want to use, choosing between the different sizes and the different angles that we have. And then the software takes care about everything else. Canova automatically sets all the printing parameter using data and tests already done. And this way, you can avoid mistakes and speed up the whole process, essentially.
What about the kind of materials that can be extruded?
Well, we have plenty of them. The Canova database already includes loads of tested and certified materials. We can see some here in the slide too. So we can range from the easier ABSs or polyamide and so on, but we have all the range up to the most complex parts and the complex materials up to PEI, Pezzo, Ultem, and those are quite tricky material to handle. But remember, if you need to work with any new material which is not maybe already in the list, you can easily add it on your list with the help of the Breton engineers. This means the operator doesn't have to worry about the complicated setting, and it can focus on the actual print and on the result that you want to get out of the machine.
So basically, the Canova software makes printing simpler and safer and reduces the risk of errors for the operator. And what we like to say here is that size and brain both matter in this case.
Yeah, exactly. Thanks to Canova, printing becomes much easier, faster, and you surely avoid the risk of error because Canova contains essentially all our know-how, all the know-how that we gather at Breton during the development, but also the know-how that is being developed by the other end users that are sharing data within the Canova cloud system that is also available. And this know-how is essentially what an operator cannot always have when it's just put in front of a new machine. So we make his life much easier. Yeah. Another strong point for Genesi is that it includes infrared thermal cameras that monitor the temperature in real time and predict layer adhesions. And then we have also a heated bed. This ensures consistent quality and keeps waste to a minimum. Yes, we are right above the head, as you can see also.
It's not heated at the moment.
Yeah, no, thanks God it's not heated, otherwise we were burning here, right? And And that's not all. Genesi is also available in what we call the hybrid version. So we have a version of the Genesi which is combining the additive with the high-speed milling. This lets you get, lets you go from the idea and the concept of the part throughout the build of the part and then the machining of the part later on. Is a solution that is perfect, for instance, for who wants to prototype and finish in the same workflow. A so-called hybrid cell is what we have here around today. It could be let me say, a sort of a little factory in your own factory. And in summary, the benefit for the operators are the ease of use, because the operator is essentially picking up the materials from the already existing software database. It also brings to the operator flexibility, because the operator can add materials to the database, always assessing also the support of Breton. It's important that we have a system to guarantee quality. So the AI optimizes every step, layer by layer, with all the projection forward till the end of the job. A fourth benefit could be that we essentially get fewer errors, because the automation minimizes operational risks. And the fifth is maybe summarizing also all the previous one, because it brings efficiency in time and material. Because with the predictive control, you can avoid waste, wrong parts, and you can get to your result better and in a faster way.
It's really impressive how AI and machine learning integrate to make the process more efficient and user-friendly. And going now to some real industrial applications that we have experience of. Enrico, could you walk us through a few examples of which industries benefit the most from the Breton Genesi process?
Yeah, Genesi is designed for a range of industries that need to produce larger components with thermoplastic materials. This includes, of course, the aerospace, which is always at the front end with the new solutions, but also the automotive, the marine, those that are referring to the production of tooling, people involved in producing energy components, but it could be suitable also for the general precision engineering works. And the applications may range from rapid prototyping to small batch production of customized parts. I'll show you some of the parts that we have been already involved in. So starting from the list that we just mentioned, we can see parts for the aerospace. So in particular, the ability of our solution to exploit at best the printing process with the very exotic materials and with the tricky materials is opening up a possibility to print directly autoclave ready molds of the big sizes, using materials that are very complex sometimes, like Ultem, Pesu, depending on which temperature the molds should withstand. But for the aerospace, for instance, we're approaching applications where we are called to 3D print fixtures and toolings and work holding systems. Holding system that could be either mechanic clamping or, like the one we're seeing now in the slide, equipped with integrated channels for the vacuum holding. If we look at the automotive sector, for instance, one of the most attracting point for the people who is interested in a Genesi machine is the capability to print directly prototypes, like the one we have here behind us today, but is also shown in the slide. So you can start really from nothing and build up your full-scale car if needed. But you can also print the components for a chassis of the car. So if you want to make a mock-up car with different section of chassis where you then put your skins on, the Genesi with its large bit is also a suitable solution. We mentioned very briefly the marine. We can see here on the screen an example of a lamination mold that we made for a customer that is producing boats in a smaller series. So that's a modular mold. It can be extended in length. It can be open also at the bow side of the boat or at the back side of the boat to easily demold the components. We spent also a mention for the architecture and design applications, like those ones we're sitting on top today, but also the one that you can see on the slides. The large additive manufacturing is really like honey for the designers. So they're all attracted by this freedom of designing and obtaining in one go the most bizarre shapes for their part. You see here from a little bit above the parts we're sitting on today, the benches, the table, the other interior works that are made available with our 3D printers. We presented also last year a very innovative way of producing kitchens. That was another example. We've been printing in one solid block all the kitchen desks. It also integrates the ceramic top on it and all the other sinks and utilities. Right. So let's see, for instance, a video of a print. And so you can see, well, it's a bit speeded up now, but yeah, you can see when it slows down, this is the real speed of the machine when printing a mold like that. That was a mold which was approximately 7 meters long, 3 meters wide, and on the top higher point, it was about 1 meter. After the print, with the same machine we're here in today, we've been doing the milling of the upper surface and including the surface finish. So the polishing, the sanding of the upper surface to make it with the best surface finish in a way that they can then apply the release agents straight on and they can go directly into the autoclave without any extra operation.
So it's fascinating, all these possibilities. And to sum up, you're saying that Breton Genesi is a cutting-edge solution for large-scale 3D printing, standing out for its integration of artificial intelligence and machine learning, which ensures a predictive, consistent, and high-quality process.
Yep.
And its versatility with both pure additive or hybrid versions, plus the simplified workflow, open up new opportunities for various industries. Yes, making the use of this technology very efficient and very sustainable.
Yeah, absolutely. But that's not just me saying that. Mm-hmm. I'm essentially quoting the words of the different end users of our solutions, and also those of the people that has been having the chance to witness Genesi in actions. I would say that for everyone interested in learning more about what we discussed today and our Genesi range and what the Genesi range can bring to your production, we have all our demo facilities and all our staff available. So just get in touch with us, and we will surely provide you the instruction and the guidance throughout the technology. Our dedicated team is ready to offer a personalized advice and help you to choose the right solution specifically for your needs, essentially. So plus we are proud also to have a network of customers and partners already using the Genesi printer successfully. They could even become suppliers for your own production, as an example, if you want to just make trials or get a pre-series batch before maybe deciding of buying your own Genesi, you can refer to our partner or to us directly. And so in the end, do not hesitate to reach out and just solicit our team of experts to explore all the possibilities you can get with the Genesi.
Yeah, of course, don't hesitate to reach out, and we will also share a QR code if you wish to contact us directly.
Just take it from the screen.
Yeah.
Please hold your phone up and take it from the screen.
And I really want to thank you, Enrico, for this thorough overview of the Genesi system, and also for, to having walked us through the potential of large format 3D printing as a new paradigm of production.
All right, thank you so much. Great. So the top question we have is, it looks like a lot of these parts are vase mode. Do you have any examples of parts that require retraction? Is that possible on these machines?
They surely possible on the machine. The parts we have here within the area today, they are just the parts we could bring in as a display. But yeah, we can build. We had the ability to print parts that, as Ariana said in the introduction, they can reach up to 30 meters in length, 5 meters in width, 2.5 meters in height. So we can really scale the capability of the 3D printer together with the machining center to bigger volumes than the parts we see here.
I think Julia was asking about the smoothness of the parts and the traction.
Right. Oh, right. Okay. The smoothness. Yeah. Because when we print essentially on large format and using these bigger bits, let's say, so we create a sort of rippled surface, which most of the time is also of interest for the architects and the designers, because they want to see actually layers on top of layers on furniture and design work like those ones. But sure, as you saw probably in some of the parts we've been scrolling over, like molds and fixtures and so on, all those ones after the printing session, they are then milled by the machine, so we can smoothen the surface, remove all the rippled surface that we have, and get to a very refined surface quality. Let's say we can really go down with the RA if need be, including the fact that we can have an automated polishing technique applied by the machining head, which brings the parts to a state where you can spray the primer of the paint straight away, like you probably see on the backside of this car as well. That has been sprayed without any extra operation. Or you can put a release agent if it's the case of the mold. So yeah, definitely. We print and we leave extra material on the surface, and then by machining and polishing and sanding, we bring the surface to the higher finish level.
I'd say that traction and smoothness depends a lot on the material being extruded. So the material which is reinforced with glass fibers or carbon fibers, especially, it's, if you don't mill it, it's really rough.
Yeah,
so
kind of.
You can get caught.
Because I think you can partially see the table we have here in the front. For instance, that's a good example. The bottom is made in glass fiber reinforced ABS, but the upper part in the same print is made using polyamide. So you have also that functionality available, which is the the one that brings you to switch between different material during the same print. And of course, polyamide is much more, let me say, glossy and better looking than the bottom side, which is charged in fiber. So it's leave the surface a little bit rougher, let me say.
Yeah.
Thank you. I have a follow-up question to that. Someone asked if retraction meant specifically that the screw would be reversing during the printing process.
No, well, it's not a reversing. The printing process is optimized in order, most of the time, is optimized in order to guarantee the best adhesion between layers, right? So by the continuous layer depositing that we do, of course, we dispense the material one layer over the other or one layer beside the other, and the shape of the layers are actually giving that form in the surface. But yeah, then it depends on the layer thickness that we apply, because we can go, depending on the flow rate that we set on the machine, we can go from very thin layers. The minimum one for a large scale printer like those ones is 1.2 millimeter. And we can go up to layers and bits of 8 millimeter in thickness. So on the bigger layer, you would see even a bigger ripple on the surface. But again, it depends a little bit on the applications. When we print bigger bits is maybe for more functional parts that are requiring high standards in functional properties, let's say. So we want to use beads that are more solid with a constant material throughout all the bead and with the best adhesion with the previous layer. When we do, sorry, just to finish, when we do more visual works or kind of parts that are maybe more for architecture and design, we tend to go thinner on layer in order to create a part that is not even requiring milling afterward.
I see, thank you. Our next question is, does the temperature observed by thermal imaging camera affect the printing parameters in real time?
Yeah, it's quite tricky. I would say not in a perfect real time, but let me explain. As we said, Canova, the software which controls the whole printing process, is based on what we have been saying. So artificial intelligence and machine learning algorithms behind that are essentially doing a sort of prediction of the part's behavior during the print, right? So the thermal cameras and the other sensors that are on board on the machine, they are there to detect as soon as possible any possible deviation from the forecast that was already pre-made by the Canova software. As soon as we detect any variation, we do not, let me say, apply the correction in a brisky mode inside the print, because otherwise we would encounter even bigger issues sometime. But Canova is starting immediately to project forward all the new information that it got from the camera and from the other sensors around the nozzle. So it doesn't matter at which layers your print is. If there is a deviation, all the following layers, they will take into consideration all the deviation you got before, and they will project forward the necessary corrections. But let me say, not in a very, very immediate way. The Canova tend to, let me say, yeah,
Professional quality of.
Yeah, it does have it keeps the focus on the final quality of the part and the final stability of the adhesion between the layers, and it takes all the necessary steps to bring you to the end in the best way.
Okay, thank you. Another question we have was, you mentioned sustainability. Do you see a role for recycled or circular materials in large format additive manufacturing?
We definitely do. So it's still at a very early stage of experimentation, but we have been doing some tests with an Italian company, also locally based, and they have this bio-based materials, like starting from scraps of like coffee grounds or.
Well, the bench you're sitting on top there is having coffee powders inside. The one I'm sitting on top is having bamboo recycled fibers.
So at the moment, it's used more for design and furniture applications. We are trying to print. Don't have the final result yet. We are trying with
PTG as well.
Yeah, and old jeans fiber.
Yeah. We got we got other materials that are embedding recycled fibers from denim. So they're giving a texture like a jeans. So it's very fine.
For now, like, we haven't reached the stability and quality needed for structural parts for aerospace or automotive, but I think we will get there. It requires a lot of
for the other materials, like those that are essentially aimed to applications demanding more technical performances, let's say, we are already consistently using PETG that comes from recycled PET. We have been recycling all the scraps that we got from our reinforced ABSs. They have been recycled. We have been using also recycled Ultem, essentially thermocomp from Sabic. But yeah, even polycarbonate is something that is quite commonly available in a recycled version, depending if it needs to be reinforced with fibers or not. But those materials, you will find them already in the database of the Canova software. They've been already used on a very day-to-day job, let me say, and so they're there.
Beginning of this, so it will grow in the future.
Incredible, thank you. Our next question is, a user asked, if you use PEEK film as a printing surface, is it meant to ensure adhesion or to facilitate removal after printing?
Well, we need to get first of all, we're not using it all the time. It depends on the material, the application, the form, the shapes. It depends also if we need to apply brims around the part as first layers. But different than other solutions that are available in the market, we do not have any need to clamp down or force down the part mechanically to the table when we print. So when we start our print, we want to have enough adhesion to get the first set of layers or the brims perfectly hold by the plates we're sitting on top. I remember that this is all a bed that is preheated in different zones according to the dimension and the shape of the part. So we exploiting the heat generated by the table and the benefits of the film in order to obtain the adhesion on the first layers. After that, once the printing process is almost at the end, all the printing bed is automatically cooled down with a regression curve that is already included in the Canova software. It takes into account also the mass of the part that we've been printing, the amount of material that is sitting on top. And during the cooling process, the films are also, let me say, kind of facilitating the removal of the part when the bed is cold.
Okay, thank you. Another question we have, someone asked if you could talk about the capability of Breton's materials science team to work with customer teams to enable the development and use of custom materials for specific use cases.
So I'd say up to now, with the customers or partners that have implemented the Genesi technology, it's always been a very, very close collaboration, because it's a technology which we realize it's quite new. So especially with new materials, we are learning together, and we are setting the new standards and new parameters of working, depending on the application and the material being used. Yes.
But yeah, definitely, I think our doors are always fully open to cooperation and the most profitable exchange of information with the experts of the end users of our solutions. I think we also need to mention as a kind of unique capability that we have at Breton, because at Breton we have a unit which is called the Breton Institute of Technology. In there we do extensive research in material, especially in composite materials, whether we're talking about plastics, thermoplastics, or other kind of materials. But we have a team of engineers and scientists that are there all days seeking for new developments and new materials. So probably those guys, they will be the right point of contact for whomever want to get more information on the specific characteristics of the materials. But the other benefits, the other advantage of our solution is that, and also it's in our, let me say, in our way of intending our role into the market. The database is made to be, the database of material is made to be expanded. We are not forcing, we're not forcing anyone to work just with the materials that we have been testing and developing so far, or not with the materials that we can provide. But we are essentially open to different type of material made by different brands and different producers. Should there be a very exotic material that we have never been testing before, etc., we will welcome any opportunity. We will analyze it with our experts, and then if it's the case, we will jump in and try and make it happen on our Genesi. Yeah.
Thank you. Another question we had. Someone asked if during the production of the product, if there's a power outage, is it possible to resume printing from the point where it stopped?
Well, that is yeah, it happened. It happens. It may happen. It happens to us. It happens also to one of our end user. So that's a very good question, actually. So what happened when we have a power outage? Essentially, there are materials which we are about to extrude, and that can be maybe stop and restart afterward without any need of emptying out the barrel and the screw, because they are maybe materials that we can reheat afterward. Okay, and maybe on those materials, in a way, we are able to restart the print over the parts, depending again on the application, because Always bear in mind adhesion temperature and adhesion characteristics for the very technical products is of the essence. So we can never, let me say, resume, for instance, a part made in Ultem if we have a power outage. But specifically when we work with those materials like PEI, PESU, Ultem, materials that cannot be reheated again once they are stopped inside the extrusion barrel, the machine includes already a set of automations which are made to bring the machine in a safe condition, to stop the machine in a safe condition, and to resume afterward the use of the machine without any particular issue. Essentially, it comes in a way that as soon as, well, there is first of all, there is a little backup time. It doesn't last very long, depending on the power we're using on the extruder at that very moment when the shortage comes. But we have few seconds where the machine can still run, okay? And if the power returns, actually we restart without any particular problem. But should the outage last a bit longer, then the machine automatically goes into a mode where it brings purging material through the barrel. It goes in a corner, in a specific corner where all the material inside the barrel can be discharged, let's say, or offloaded from the barrel. It purges all the extrusion line, and then it goes in a sort of parking mode. Waiting for the power to come back. It's all automatic, it's very safe, it's just enough to leave the purging material loaded into the loading hoses that we have on the material feeding system beside the machine.
Thank you. I'll ask one more question. We're almost at time. Someone asked if it was possible to use non-continuous deposition strategies.
Well, it's possible. It's very challenging. It's very challenging because, as we said, we are extruding large quantities. Okay, so consider that our smaller extruder, the smaller extruder that we have in the range is an extruder that can reach up to 60 kilo an hour, right? So the capacities that we're normally working with are for large amount of material per minute. We can jump from point to point because we have optimized strategies for start and stop. That's what we call start and stop. So for every material, there is a perfect sequence to stop the nozzle, make the feed just at the right point to avoid any bar, let's say, on top of the part, or any bar on the point of contact later on. But by the nature of the extrusion system that we have, we cannot make that non-continuous print, that fast non-continuous print as the one we are typically able to see in the smaller 3D printers, smaller FDM or smaller desktop 3D printers. Our process is more like a continuous layer deposition. So it's that's the best way to use it. But imagine to have a need to produce more parts that can be sliced with the same with the same height on the layers. Then you can exploit the machine at its best, because you can in a larger area you can put many parts. And the machine can jump from one part into the other. And so maybe in the same time you would simply print one part, you can get multiple parts. because remember the time is driven by the lap time, no, by the temperature we should find again on the layers. So typically, well, if you see like the benches we are on top today, they've been when they were made on the same material, they were printed together on the same printer, and essentially the time we could use in printing one is the same one for printing two.
Wow. Thank you so much for answering all of these questions and for your entire presentation. We didn't get the chance to answer all of these questions, but I'm sure the people who asked them can contact you, and that you'd be happy to.
Yes, of course.
answer the
We'd be happy to
questions.
answer and have a chat.
Yeah.
Yeah.
Well,
Yeah.
if you need a hand, we have two each. Okay, so we're plenty, and we're here to help. Yeah.
Thanks, Julia, for moderating.
Yes, thank you all so much. And a reminder that this webinar was recorded and you can find it on the 3D Natives website and Vimeo afterwards. Thank you all so much for your time today and for attending. I will end the webinar now. Thank you. Bye.
Thank you.